This is a case example related to PAT sensor optimization. So the case at hand here was actually also published scientifically. You can see the reference at the bottom. And this work was actually conducted by the people at Ghent University. That was actually the lab we are a spin-off company from. So these people have done quite a nice practical study, and I will just outline it a bit here. So at one hand, you have a vessel, a holding tank of 150 liters holding an API solution, and you have to stir it continuously. Some foam was being produced. It's not really desired. So that's, of course, a specific question where you can look into with CFD, how to minimize foam formation. But this was not the question here. So the problem was, because you have foam, the level of API you have in your foam compared to your boat suspension can differ a few percentages. So you can have somewhat more API in the foam, for example. So it means when the process goes further and progresses, your concentration at the outlet, if you're pumping with a certain flow rate, might also start changing. To have better control on this and when to stop the process, these people actually decided to put an NIR sensor inline to have a very good idea on the API concentration. Of course, such a sensor is put in a channel. You can see here the flow is coming through and the sensor is like lateral to the flow with a window. Of course, ideally, your sensor online gives the same readings than your offline liquid chromatography measurements, which are the yellow dots. This was not really the case initially. You can see that there is some signal disturbance, not really caused by the foam, but caused by something else. So if you, these guys have actually analyzed the channel. You see a lot of turbulence going on here. And this was causing these flow patterns, non-optimal flow patterns in this measurement channel were causing the disturbances you see here. So this is actually a CFD analysis of this channel. So it's a channel of a few centimeters in diameter. So, well, then you can use CFD to redesign. And one of the questions was, can we maybe make this pipe a bit longer to have a better flow development? And then how much longer it should be? And you can see if you make it longer, indeed, you have much less turbulence, much more streamlined flow in this channel, and ultimately leading to a much better signal stability. So this was really a nice outcome of this case study. So using CFD to redesign equipment rather than just doing trial and error based troubleshooting. It was a very efficient way of solving a problem.